I'm going to ask that you hold all questions until the very end, because I'm about to tell you a story. And we do not want our story to be interrupted.
Wait.
Clara?
Is it a spooky story?
No, it's not. It's actually a very amazing and special story.
But why do you have a flashlight then?
So that we can kind of demonstrate certain
And you're
things.
holding it up to your nose like you can.
Yeah.
Yeah.
Okay, are you ready?
Can we laugh? Yes.
Now, the first thing that I want you to envision is total darkness.
I can imagine that. What happened? This is easy.
I don't think we're ready to start. Because 13.5 billion years ago, the universe that we know of was filled with complete darkness. Every molecule that is in your body was inside a giant ball that was at the center of our universe. There were no planets in our universe because every molecule inside those planets, all the gases and the rocks and the water of those planets were inside this one giant ball. We don't know what the giant ball looked like, but we know that it had incredible energy. And it is sort of like a crowded room, maybe a very cold, crowded room. Because space is so cold, it's negative 450 degrees. And all those molecules were so cold in space that they were huddled together. And as they tried to get warm with each other, the molecules on the outside were trying and pushing and trying to squeeze in. But the molecules that were on the inside were getting squished and squeezed, and they were getting hotter and hotter because all the molecules around it, the molecules of the entire universe, were squishing in on them. And as they got squeezed and squeezed and squeezed inside the giant ball, they feared that they couldn't take it any longer. Until the squeezing was so intense that they couldn't take it anymore. And then it burst.
Kyle, do it. Yeah, do it.
When it burst, there was no sound. And that is why we had the flash of light. Because in space, there is no sound. There is nothing for sound to bounce off of in space, and so it would have made no sound. Instead, there would have been that great flash. Turner, why don't you flash it one more time?
Well,
Like that.
that hurts my.
And when it flashed, it released pulverized particles, sending them out into every direction of the universe. Those particles were so small that even today, with our most powerful instruments, we cannot see them. We know they're there because they're still moving around in our universe today from that explosion. And those particles are called dark matter. The dark matter has a type of energy where we can see them pushing particles away. Similar to the way that magnets might push themselves away. But some of the particles are attracted to each other, and they like to stick together. As those particles start sticking together, they roll together in that cold space, trying to get warm, and it acts much like building a snowball. where these smaller molecules roll together and eventually you get bigger and bigger molecules. When the molecules finally got big enough, they created something very special, which is called elements. The first two elements ever created were hydrogen and helium, and they have special numbers, 1 and 2. We will talk about what those special numbers mean later. But what you need to know is that those molecules were floating around in space and they were really, really cold. And as they started looking for other molecules that were similar to them, they started swirling around and like big clouds of gas. And those big clouds of gas drew the attention of more of these molecules and these elements. And they started getting warmer and warmer and warmer until these clouds of gas were so big that they created nebulas. The nebulas are a result of the hydrogen and helium particles swirling together, trying to get themselves warm. As more and more of these particles come together, they get more and more powerful, and the nebulas soon swirl together to create the very first suns.
Carl, got to use them later.
And for the very first time, our universe began to see light and feel heat.
Don't burn the school.
Some of these suns were very small, and some of them were very big. But all of these suns worked very similarly to that one giant ball that used to exist in the universe. It has gravity. And so all the suns would attract other particles and gases. Sometimes they were big and strong enough to become really, really big suns. Sometimes they weren't that strong at all. But on the inside of these suns, they were doing the same thing that that one giant ball was doing. They were crushing particles on the inside. Just like a crowded room. And those particles on the inside were getting so squeezed and so hot that that's what makes the fire of the sun. And as they get squeezed, a special math problem starts to happen. Remember how we said that there was special numbers, 1 and 2. Well, when you put 1 and 2 together, you might get 3. And suddenly a new element was formed called lithium. You can add 2 and 2 together and get another element called beryllium. Or if you add 1 and 2 and 1 and 2, you get 6 for carbon. And if you add 1 and 2 and 1 and 2 and another 2, you might get oxygen. So on the inside of these suns, as they were squishing and squeezing all these elements, what they were doing were they were creating new elements. And they created over 100 new elements, all on the inside of those suns. But when a sun squeezed too hard and couldn't squeeze anymore, the suns would die and they would explode. And just like the smoke that rises from a candle, it would release these new elements into space, allowing these elements to make new things. And when the suns exploded, suddenly there were rocks and meteorites and all kinds of new elements that would help make planets. Now, do you remember when I said that some of the suns weren't big enough? Believe it or not, our planet tried really hard to be one of these suns. It started out as a swirling ball of hot gas. And it tried really, really hard, but guess what? You gotta be a certain size in order to be a sun. And our planet just wasn't big enough. But on the inside of our planet, you can still see it trying to be a sun. And that's because it's squeezing those particles on the inside and making those particles really, really hot. But try as it might, it will never make them hot enough to turn our planet into a ball of flame. Instead, we have lava and we have a hard core. And on the outside, a crust to keep the heat in. And we'll talk more about how our Earth was made. But for today, this is all that we have to tell you in the first grade lesson.
That was awesome. No, it was really fun.